Okay, so let's look at a situation where our phase constant's not zero, or we don't start by releasing it at our maximum positive displacement. But we've started our time when it's somewhere else. In particular, let's suppose that we've watched this oscillate, and now it's moving towards negative, but it's passing through this equilibrium point. So this is the picture, and its velocity is that way. Okay. So it's at equilibrium, its velocity is in the negative direction. Where would that be on this circle? Okay. At an earlier time, it would have been over here at maximum displacement. And we know that on our circle, we always consider the motion to be counterclockwise. So it was over there, and now it's moving back. It's got to be either here or here on our circle because it's at our equilibrium along our x-axis. Okay, so this is still our x-axis, but we're looking at kind of a circular motion in an xy plane where y really doesn't mean much to us, except that we're using the projection of the circular motion onto the x-axis. Okay, so it's either here or here on our circle because it's here at the equilibrium point. So which is it? How do we know which it is? Okay, well, if it's moving this way, and our motion on the circle is always counterclockwise, it has to be up here because that is continuing to move in the counterclockwise direction, which its projection means it's moving to the negative direction. It's moving towards negative A. So as this pretend dot moves towards negative A, our x projection also moves towards negative A. So we'd say, oh, it's right here then. Okay, now if that is at t equals 0, then this quantity right here is 0. Okay, this is 0, and so cosine of phi 0 must equal 0. So in this case, we have cosine of phi 0 equals 0. Okay. Well, we know that cosine of 90 equals 0, or cosine of 270 equals 0, which is basically saying it's here or here, which means we're starting at 90 degrees or 180, but given our velocity, we knew it had to be 90. And so now that means our phi 0, our phase constant, our initial starting point, must be 90 degrees, or better yet, pi half radians. Okay, so that's how we were able to determine our phase constant, is considering this motion to be circular motion and looking where it might be on that circle. Okay, so now we've found that phase constant for this case. Well, what if we were still at this origin, but now we're moving to the other direction? So an alternative is we're moving, I'm going to do a V1 for an alternative case. Then, well, where are we starting? Well, it's at the origin, so it means it has to be here or here. But since we're now moving that way, our counterclockwise motion continues that way, giving us moving towards positive A, which means we have to start down here. Which in that case, we'd have phi 0 of from here all the way to here, which means that's going to be 270 degrees, or 3 pi halves. Okay. And since it's a constant, we could have also just measured it from here. Though our motion continues counterclockwise, we could have said this is negative pi halves, because our time would still be moving forward and we'd be moving from negative pi halves, continuing that way. So that would still work.